Now let's take up question number 21. Here this question states, find the remainder when x raised to the power 51 is divided by this polynomial x square minus 3x plus 2, where we have these four options for the remainder. So let me tell you, this is a question related to division of polynomial, and you're very well aware about this division algorithm. That is, dividend is equal to divisor into quotient plus remainder. That is the major concept that we are going to apply here. So very first, as we are talking about this polynomial being divided, so this is the dividend, and here what is the divisor? Divisor is x square minus 3x plus 2. So x square minus 3x plus 2 is the divisor. Let's say there is some quotient q of x and some remainder. As you can see, divisor is here a polynomial of degree 2. So the remainder will be either a polynomial of degree 1 or degree 0, because always, the remainder has a degree less than the degree of divisor. So let me consider that the remainder formed here is ax plus b. Okay, this is the remainder. So now I'm sure you're very clear with this fact. Dividend is equal to divisor into quotient plus remainder. Alright. Now in this statement, I want you to focus on this divisor x square minus 3x plus 2. This is a quadratic polynomial which can be very well factorized, and you can split the middle term to factorize it. The moment you will split the middle term, you will find here this is x minus 1 into x minus 2 into q of x, that is the quotient, plus remainder ax plus b. Alright. So here we get this very easily. Let this be equation number 1. Now from this, it is very clear that the divisor has got two factors, x minus 1 and x minus 2. Now we will be doing some simplifications over here. Let's observe equation number 1. Now let me substitute here x as 1. Now what will happen if you substitute x as 1? This will become 1 minus 1, 0. And here this whole term will become 0, because 0 into any quantity ultimately becomes 0. While here this will become a into 1 plus b, that is a plus b equal to here 1 raised to the power 51. Now substituting x equal to 1 in equation number 1, we get here on the left hand side you will be getting 1 raised to the power 51 equal to, here this is 0, plus we have a into 1 plus b. That is, I am getting here a plus b equal to 1. Let this be equation number 2. I hope that's clear. Now as we have substituted x as 1, in the same way, another factor is x minus 2. How that can become 0? You need to just substitute x as 2. The moment you will substitute here x as 2, this factor will become 0. 0 into any quantity, this quotient part will become 0, and here this will become twice of a plus b. Alright. So let's substitute it here. Next I am going to substituting x as 2 in equation number 1, we get on the left hand side you have x raised to the power 51, so that is going to become 2 raised to the power 51 equal to, this is 0 plus twice of a plus b. So you can further write it in a simplified form as 2a plus b equal to 2 raised to the power 51. Alright. Let this be equation number 3. Now I want you to focus here on this equation number 2 and equation number 3. Here this is equation number 2, a plus b equal to 1. This is equation number 3, which is twice of a plus b equal to 2 raised to the power 51. In this question, you need to figure out the remainder. And what we have considered as remainder in this question, you can clearly see the remainder portion is ax plus b, which totally depends on the values of a and b. So let's try to figure out here the value of a and b by solving here equation number 2 and 3. So subtracting equation number 2 from equation number 3. So let's do the subtraction so that we are able to figure out the values of a and b. Alright. So this is equation number 3, twice of a plus b equal to 2 raised to the power 51, And here I have equation number 2, a plus b equal to 1. Alright. So we need to further simplify this. In this case, you need to change the sign while doing the subtraction. Here plus b minus b gets cancelled. 2a minus a gives me here the value of a equal to 2 raised to the power 51 minus 1. So this is the value of a. Now I have already obtained the value of a. This value of a can be very well substituted back in equation number 2 to get the value of b. So next, substituting a in equation number 2. Substituting a equal to 2 raised to the power 51 minus 1 in equation number 2. Then in that case, equation number 2 is a plus b equal to 1. So that will become 2 raised to the power 51 minus 1 plus b equal to 1. So you'll see all these constant parts will get transposed to the other side, and I get here the value of b equal to 2 minus 2 raised to the power 51. So here we get the value of a and b. Now using that, you can very well get the required remainder after the division process. And that's why I conclude the remainder is, so the remainder is ax plus b, where we have figured out the value of a is 2 raised to the power 51 minus 1 whole into x, plus b, which is 2 minus 2 raised to the power 51. So here we are getting this as the required solution. Okay, so let's try to observe the options here. In this question, we have got these 4 options. Now where you can figure out the right answer. Our answer is 2 raised to the power 51 minus 1 into x, which is found here in option C, plus 2 minus 2 raised to the power 51. So we clearly get here the required answer as option C. So you can very well mark your answer for this question as option C. I hope it is totally clear to you. So this was the question related to division algorithm. Let's proceed ahead. Here we have question number 22 related to inequality. It states that if 3 upon x minus 2, this rational function is less than 1, where x is a real number, then which of these option is correct? In option 1, x lies between 2 and 5. Here in option B states x is less than 2 or x is greater than 5. In option C, x is less than minus 2 or x is greater than 5. And option D states none of these is correct. So let's try to solve this inequality first. Here in this inequality, we have 3 upon x minus 2 less than 1. Now let me transpose 1 to the left hand side in order to solve it. So I get here 3 upon x minus 2 minus 1 less than 0. Alright. So I'll be taking here LCM on the left hand side, which gives me 3 minus x minus minus plus 2 upon x minus 2 less than 0. Proceeding ahead, here this will become 5 minus x, okay, 5 minus x upon x minus 2 less than 0. Now if I take here minus common from the numerator, this will become minus of x minus 5 upon x minus 2 less than 0. Now what happens in case of inequality? If you multiply a negative quantity both the sides of inequality, the sign of inequality changes. Right? So we have a minus sign here. In order to eliminate this, I'll be multiplying minus 1 on both the sides. The moment I multiply minus 1 on both the sides, this inequality changes from less than to greater than. Okay? And here it becomes x minus 5 upon x minus 2 greater than 0. So this is the inequality. Now on basis of this, we'll try to figure out the possible values for x satisfying this condition. For this, we will be using wavy curve method. Alright. So let's use here the wavy curve method. If you want to figure out the wavy curve method, first you need to figure out the critical points. I have here this factor x minus 5. When it is equated to 0, it results the value of x as 5. And when x minus 2 is being equated to 0, it gets here the value of x as 2. So we have got here two critical points, 2 and 5. So I could very well write by wavy curve method, we have here the number line, okay. So I'll be putting here the number line in order to represent these critical points. So on this number line, here I have two critical points, 2 and 5. If you follow the wavy curve method, so on alternating ranges, I will be putting here positive, negative and the positive sign. So following the wavy curve method, here you go, positive to negative, negative to positive. So here we have positive, then alternating negative, then positive. Now according to this fraction here, this quantity has to be greater than 0, where the positive values lies for this rational function. Positive values lies from minus infinity to 2, where 2 is not included because this is the inequality of just greater than, and from 5 to plus infinity. So in other words, I could say here the value of x which is satisfying this condition is clearly given by x less than 2 or x greater than 5. So this will be the required condition here for this inequality to exist, where x minus 5 upon x minus 2 is greater than 0. We have the positive values of this fraction lying from minus infinity to 2 and then from 5 to plus infinity. I hope this is clear. So this is the value of x satisfying. So I could say now that where x is real number, then the value of x which is satisfying this condition is clearly x less than 2 and x greater than 5. So you can clearly see that option is found rightly here in option B. So we get here the correct answer for this question in option B. You can very well mark your answer as option B. I hope that's clear. Let's take up our next question.